Hi, my name is Eric Lloyd. I'm CEO and co-founder of Brink Bionics. We're a deep tech neural technology company developing neural interfaces for gaming and esports.
So when you say neural interface, you literally mean like telling your brain to click the mouse button and then have the computer do that command or move the mouse. That's basically what it is.
In a sense. So when the term neural refers to brain or peripheral nervous system. So what Impulse is doing is grabbing peripheral nervous system data. So when you intend to move a muscle, your brain sends signals to your spinal cord, then little neurons in your spinal cord send specific coordinated commands to all your muscles. And those muscle signals, those commands to the muscles, is what we read. And that's what I have with Impulse here. So Impulse measures the electrical signals that manifest in the muscles that come from your peripheral nervous system.
And that whole synergy of system that moves your muscles in your hands or tells you to blink or breathe, that happens in like so fast. Like it's almost instant, not instantaneous, but it might as well be, because the second I think I'm moving my finger, there is that all that stuff is happening. So does your technology like measure what that synapse is to click the mouse, record that, and then spit it out into your software? How does it work?
Yeah, so basically, thought, the process of going from a thought to a movement, there's actually a bunch of instances of major delay in that chain. So if you compare human beings, like the speed nerve signals travel down your nerves to the speed of electrical signals in a wire, they're not even comparable. Your nerve signals travel as fast as like the fastest sports car in the world versus half the speed of light. So there's a big difference between those two. So there's delay in your, if you initially see a visual input, there's delay in you processing that visual input and determining what output you're going to do. There's delay in the time it takes that nerve signal just to travel down your spinal cord to your muscle. And then there's the delay that we focus on, which is called electromechanical delay, EMD. So when the nerve signal reaches your muscle, there's an electrical event that happens inside the muscle, and then the muscle starts to contract. And that contraction obviously takes time to build up enough tension to perform an action, like clicking a switch. So what Impulse is doing is it's reading that electrical signal as just kind of like how you said it, it's reading the electrical signal as soon as it hits the muscle, and it's sending it to the software. So it's not making your finger move, but it's talking to your computer so that your finger doesn't have to, basically. And
you're talking about I'm not an engineer or a scientist or not good with math, but like, is there something faster than milliseconds, microseconds? Is that a thing? Like, how do you measure that time?
So basically, the way we determine the advantage that Impulse gives, the benefit is that it's designed to be used with your gaming mouse. So with each click, we provide real-time feedback between the mechanical click and when the muscle click was read. So we can give you real-time feedback on the difference between those two. I don't know if that answers your question.
No, it does, because like that, I mean, in the competitive game set, like that measurement of time between clicking the mouse and when you're thinking to click the mouse can be the difference of you winning or losing.
Yes.
That's why
Definitely.
So many esport people retire at 30, because your synapses, your reactions aren't that fast anymore. It's nothing personal, just age. You get slower as you get older. Your synapse faster, your reaction time lowers as you get older. That's why so many people who are 18, 19 are so good and so fast in these games.
Yeah, I can't compete with. I'm 27. I can't compete with them anymore.
No, you're already you're on the cusp of like retirement. You should have retired 10 weeks ago. You still play in hopes. Yeah. No, my question was like, what is the unit of time you use to measure that difference between clicking the mouse and thinking about clicking the mouse?
In this case, it's milliseconds. So so there's a long time delay in reality between the intention to click and the click. So a muscle contraction, I mean, it depends on what you're trying to do, how much force is required, but between the electrical event and enough tension building in the muscle to perform a movement or an action, it can be up to 150 milliseconds of delay. So 0.15 of a second delay between the signal reaching the muscle and the muscle generating force enough to perform that task. So the delay is significant to the point where, pro gamers are complaining about anything more than 60 milliseconds of ping. And you start to see the time scales we're working at, where if 60 milliseconds is starting to matter in terms of latency, then you can start to see how, if we're measuring, things in the nervous system in tens or hundreds of milliseconds, how shaving that time off can have a huge impact on performance.
And that's so how much, like, was it difficult to implement? Because obviously you lose time in post-processing for it to go through your platform. How difficult was it to make that as streamlined as fast as possible?
So that came down to like selecting the right programming languages and everything to ensure we have super low latency as much as possible. That's when my co-founders. So to give some background on the company, it's myself and my two co-founders who are leading researchers in the field of neural interfaces and muscle signal technology. They're the ones who really developed the core algorithms that make Impulse work. So the key to your point was making something that could run what did not require a lot of processing power, could run super low latency, and didn't need a lot of data. The big thing with any type of biosignal processing is needing as little data as possible is a difficult problem. I'm sure you may have seen in the past like muscle signal armbands that detect your movements, or prosthetic devices that use muscle signals to be controlled. Those control systems, the way they usually work is they collect, anywhere from 50 to 250 milliseconds worth of data. So the algorithm will wait, and it'll wait in time and collect enough data. And then once it has this chunk of data, what's called a window, it'll make a decision based on all that information. But the problem is you can't use that for gaming, because that would be like having a mouse that has a quarter of a second of a delay.
Yeah, right.
So the challenge was being able to develop algorithms that could make a decision on a few milliseconds of data. So having 3 to 5 milliseconds of data, then we know what your intention is in the concept of gaming, and then we send that right to the computer. So that's the challenge that my co-founders overcame.
And it does help that you're not collecting, it's only like your mouse finger. You're not collecting data on an entire arm of intricate muscles and wrist movements and stuff, because we've seen the prosthetic arms before at certain CS events and stuff like that, and it's really cool. But like by the time you think about moving something, it takes 4 or 5 seconds, and then it does it. So it's a big delay because there's so much more information with the multiple fingers and the tendons and the wrists and stuff like that. Where yours is the mouse, specifically the mouse finger, correct?
So we do left and right click right now.
Left and right click. Okay.
Yeah. There is potential to expand it to more functions, but we focus on those two, mostly focused on FPS gaming initially, because left and right click is shooting in ADS.
So people right now can use this data as a way to self-improve, correct? To look at their, see how, and to improve their times or improve how they play the game. Basically, is that what the end goal of this is for right now?
So that would be more as a training tool. We're looking at that as a potential direction in the future, but right now it's a real-time peripheral, a real-time input. So instead of just relying on your mouse to click, Impulse will send a click signal to your operating system as a left click, and you can use it in real time to play a game. So it gives you the real-time click-by-click advantage.
Oh, okay, because I was watching some videos and I was like, okay, so it's a tool that, because it was a side-by-side comparison. I'm like, oh, so you see how fast you would have been, but no, it actually in theory works. Like use it to play Counter-Strike or whatever, League of Legends, whatever.
And each click is faster. Yeah.
That's intense. That's really intense. How you, obviously this is in the hands of like certain people outside your group and probably some kind of closed beta or something, but what's it been like getting this data back to you and improving your platform and your hardware?
So that's the thing that we've wanted to do. I mentioned at the beginning where we call ourselves sort of a deep tech company. We're not quite a consumer technology company. Right. We call ourselves deep tech because there's a long way to go between where we are now and where we want to be with this technology. So there's a lot of research in between. The difference for us is we have aspects of the technology like this version of Impulse that we can give to gamers and say, okay, what do you think of this? How can we change and improve it? In working with our early beta users and for our first launch of Impulse in May, our first ship of our first few hundred units, with those users as well, the key is gathering critical feedback and figuring out how we're going to change this product in the future. There's about 10 different technology development directions we have on a roadmap that we could build out to, but we can't do them all at once. We need to figure out what's going to work best for gamers. So this version of Impulse is really a way of saying to the gaming community, here's neurotech, here's what it can do. How are we going to make this and fit it to where you want it and get it away from the areas you don't want it?
And like, I feel like the software, I mean, you get that data back and you can tweak and manipulate the software, but I feel like when it's a hardware issue or a hardware upgrade, it becomes a little more difficult because you have to figure out how to fit it in the current peripheral. And if you're doing it, and if you ever do get to consumer level, like mass producing that and have it be cost effective, just the engineering side of that alone's got to be a lot of work.
It is, and that's why the common phrase amongst hardware startups is hardware is hard, because it is a lot more capital intensive than conventional software. The benefit is the big improvements that'll come from our technology. There's part of it's hardware, but a lot of what made our technology successful so far is the algorithms.
Say like I have are there medical benefits to this or maybe disabled benefits to this? Like if maybe I have carpal tunnel and I can't move my hand very well, or I can't feel my hand, you know what I mean, or I have bad arthritis and I can't really click fast. Could I lay my hand on the mouse and essentially use your platform to help me play a game?
We've had a lot of feedback from people about wondering whether it has applications for, people who need alternative control systems. There is, and that's where my team's background comes from, prosthetics. So that direction of helping people who need alternative interfaces is something we're passionate about doing. All I'd say is we haven't run any formal studies in that direction, but there's definitely the potential there.
No, I mean, I have to say, with like Cyberpunk coming out this year, I mean, obviously we've seen a lot of fun stuff. The human mind's very creative. You're an actual engineer in this sense. Like, how many years do you think we are from a point like that we can actually plug in arms in and out of our bodies and switch out adapters and have full bionic arms that respond instantaneously to our brainwaves?
It's a conversation I'd love to have. It depends on a number of areas. So if we want to dive into for prosthetics, we'll look at prosthetics as one area. So in terms of there's a couple different areas. There's sensory feedback, there's the robotics itself, and then there's the control systems. Sensory feedback in top, U.S. military research by the Defense Department and DARPA is early stage. So you can actually send basic sensory signals from advanced bionic limbs back through the nervous system. And that's in the early stages of research, but it isn't quite at human level yet. The robotics side, in some sense, matches the degrees of movement and the strength in the top prosthetics in the world. So the MPL, developed, I think, through Johns Hopkins University, is the most advanced bionic limb in the world, and it matches in many ways the average strength of a human limb, which is crazy if you think about where we were just 10, 15 years ago in prosthetics. So if we're looking at a timeline, the robotics will reach over human level performance within 10 years. It won't be affordable. You're talking $500,000 for an arm.
Right.
But in terms of feasibility, that's reaching that point. For the control systems, what's been a big direction in the space for biosignals in general is exploring how artificial intelligence and machine learning algorithms can be used as the translator between the human nervous system and the machine. And basically what that means is, if someone needs a new prosthetic limb, you teach it the patterns of neural signals that the users would have initiated to move their natural limb, pass that to a machine learning algorithm which learns those patterns, and then after it's been trained, it can translate nerve signals into artificial movements for a bionic limb. So that's being heavily explored in academia over the last 15 years, 20 years, and now it's seeing commercial implementation. So the control systems will reach a point in the next 15, 20 years where it will be able to do everything our natural limbs can do. Most of that will be through implants or surgical modifications. There are limitations in using wearable technologies to be able to get that kind of human level control. So it'd likely be through implant technology, either through peripheral nervous system implants, so implants in the muscles or in the nerve fibers, but also through technology that Neuralink is developing, Elon Musk's neurotech company, through high density cortical implants. So that basically means a bunch of tiny wires plugged into the surface of your brain to collect a lot of data and use that for control. So I'd say probably 20 to 30 years before it's technologically feasible. The other monster to overcome is the surgical side of things. So while technologically we'll be able to build limbs that will outperform or match human level performance, the problem is removing a limb and replacing it with a prosthesis is invasive no matter which way you slice it, no pun intended. So the feasibility of cybernetic augmentation is what we're starting to see now. Whether or not we'll see a world quite like Cyberpunk where you can swap your limbs for tech, I think that also comes down to the social taboos. I think nowadays if you go to the average person and say, hey, want to swap your arm for technology, no, they'll say no. But maybe that social stigma will change as neurotech becomes more prevalent through society through non-invasive technology. So wearable technology that interfaces with the nervous system will make, I think, people more comfortable with the idea of interfacing their brains and nervous systems with machines. And maybe that will lead one day to a world where people are very much human and machine.
That's crazy. It just like you said, it all starts with people like yourself, like a starting point of doing stuff like this, like neurological studies and impulse control studies and stuff like that, and creating a device that can measure something as simple as a mouse click with the thought of your mind sending a signal to your hand. That's where it starts, right? And then it just goes on from there once you get that baseline done and you get And with the technology improving every year, you just get more and more resources, hopefully more resources, more and more grants to keep studying this and improving it and eventually helping the human race. This is what people like you are doing. You know what I mean? Like, this has so many implications, not just from the esports standard, but from all different ways of life, you know?
Exactly. Yeah, exactly. And it's going to take, and we know, initially building our first versions of this technology, as this technology gets released, we saw the same thing, with computers and ways of interfacing with computers back in, the 80s and 90s. There were a lot of companies that got it wrong before people started to settle on the things that worked. You're going to see the same thing with neurotech. You're going to see lots of weird and interesting technologies come out as the industry understands how best to build this technology for its users. And Impulse is one of those technologies. This likely won't be the final form of the technology we develop, but it's a stepping stone to figure out what people want and how to get there.
Would you call, because you said you've already produced like 100 or so units, would you call that still like a prototype unit at this point?
So I'd say it's a small batch
Okay.
production. So we are doing a full manufacturing run of those units. But in terms of where we want to be in the end, it's a very early version of our vision for what this technology can do. Not quite prototype, more closer to the manufacturing side, but there will likely be lots of changes to it after this first batch ships out.
As is all R&D projects, you know what I mean? There's always,
Yeah.
I've seen Kickstarter, I know how this works. You buy it, and then a year later, there's a much better one, you know? But that's just
Yep.
how it works. My curiosity about your devices, you ended up going with a hand adapter. Did you ever fool around with the fact with just a mouse peripheral, or maybe a mouse and hand peripheral? Like, what made you decide that the hand thing was the best way to go?
So part of it was before we actually started building anything, we went around, spoke with gamers around our University of Waterloo lab, just a strong gaming community at the University of Waterloo, and tried to understand, what do gamers like about the existing peripherals? And a lot of it comes down to, ergonomic factors and personal preferences for different peripherals, as much as it is performance. So what we didn't want to do was build a device that forced gamers to replace what they're already using. So that's why we went with sort of the wearable glove instead of something integrated into a mouse. So it's like, use everything you usually use, but with Impulse.
Now, we spoke about this a little bit before the interview, but like, do you think your product in general will cause ripples in the esports community as like, a set of rules, or like maybe cheating? Oh, well, you're cheating. You're using your neuro to do the mouse click. You have to use the real mouse to be a man. That one of those things.
It's possible. We're really stepping into an uncharted territory in terms of how professional esports will view neurotech. The perspective we've taken is that, companies like NVIDIA with their new reflex technology, or Logitech with Lightspeed, also try to reduce latency. You can buy those technologies, plug them into your computer, and you're faster, and it has nothing to do with you as a gamer. So we're very much the same thing, just the way we achieve our advantage is different. So that's the perspective we take. Whether or not the gaming community sees it as the same, we've seen a lot of controversy around conversations on both sides of it.
And Eric, how did someone like yourself get into this technology and field? I mean, you're fairly young. I mean, none of this stuff was available when I was a kid. I probably would have maybe pursued it instead of being a creative. But like, how did you fall into this industry?
Yeah, my career path was weird. So originally I started my undergrad. My undergrad is related to nothing what I'm doing now. I did is chemical engineering and process automation technology. So more for industrial engineering for like industrial manufacturing settings. I had an interest. I played Deus Ex Human Revolution when it first came out. And as soon as I finished that game, I'm like, that's what I'm going to do. Because that game was so cool. I loved everything about the story and the technology in that game. I'm like, I have to do that. So I built my first bionic arm as sort of a prototype in my last year of my undergrad, and then I showed it to my university professor, now one of my co-founders. He accepted me into his lab for my master's, where I did research into artificial intelligence controls for bionic limbs, started to build some prototypes in the lab, and then we turned those prototypes into Brink Bionics. We started as a prosthetics company. And then as we went through prosthetics, we looked around at the other companies around the world, and we're like, oh, there's a lot of companies actually doing the same thing we're doing, which was artificial prosthetics integrated with artificial intelligence. So we were like, our major thought was, okay, well, do we keep doing the same thing that all these other companies are doing such a great job at already, or do we pick something totally crazy and new to try? And that's when we pivoted to the gaming technology with Impulse. We decided to try something that no one's done before, which is build a peripheral nervous system interface that is specifically tuned and built for one application in mind, and that's gaming.
So how is because I have to ask, because I mean 2020 was kind of crazy. How has the COVID and stay-at-home orders affected the development of the cycle, if at all? Because some people are already working remote.
Yeah, so our team has been pretty remote working from the start. We're a small team, so there hasn't been a ton of change in terms of coordinating people. We were fortunate that way. So basically what changed is we were no longer able to work in our offices. We all had to move home. Most of the development by that point was me soldering together beta units in my apartment. So my apartment basically turned into our production floor, full of boxes, barely livable. But that's the startup life. And but aside from that, yeah, everything shifted to my apartment. Got a 3D printer to use to print out all our early prototypes, and then from there, we were actually able to raise a fundraising round during COVID, which was amazing because we absolutely needed to get the money on board to push this forward. So COVID had its bad in the sense that it forced people to be home. It made everything kind of uncertain as we were trying to get ready to sell a product and raise money. But it also, I think, had an interesting benefit because esports is one of the few industries, not small, but few industries that saw growth during COVID because everybody's at home playing games, and people who may not normally play games as much are jumping more into this sphere, which is unique. I think if we were still a prosthetics company in the early stages and we hadn't pivoted to gaming, we would have been in a much worse spot during COVID.
So that you raised your own funds? Did you have private investors looking into this? Like how is this project funded so you could actually, pay your rent while you're doing these cool things,
Yeah, so a lot of my work was done through Brink Bionics was done during my master's, so I had funding through the research lab, which kept me fed. And then from there, we had some private initial investment from some angel investors to keep us going for the prosthetics technology. We had grants one was from the Accelerator Center in Waterloo, and another grant through FedDev. So federal government matches a certain amount of funding. We had to find 30K of funding in the federal government through the Accelerator Center matched with another 30 grand. So that grant helped get us through. We had another grant from an incubator that we're a part of called Velocity. And we won a pitch competition through them, got some grant funding, and then we raised our pre-seed funding round with two private investment firms, Risk Capital and Hello Ventures, just this past August.
That's great, man. Where can people go to find more information about your product?
So right now, if you go to brinkbionics.com, it'll pull you right to our Indiegogo page, which is basically we're using as our pre-order page now that our Kickstarter is done. So if anybody missed it on our Kickstarter, they can go there either to learn more information or to pre-order if they're interested. So that's where we have the information right now, and we'll have a new website going up at that same link, brinkbionics.com, in the near future. As well, if you want to keep up to date on what we're doing and any new news or media coming out about us, you can follow us on Twitter at Brink Bionics.